Hello everyone, today we'll talk about the solution to the problem check if array is sorted and rotated. Since this is just a single check that we have to run on an array only once, we don't have to think about stuff like binary searching. We can simply do a linear search and try to answer the question just by going through the array linearly. And let's see what we can do. How can we approach solving this problem? Well, we know that, of course, if there was no rotation, so this was this zero rotation, the array will be sorted. So if the array is sorted, then we're happy. Otherwise, after this rotation, we're going to be having some suffix of the array, and the corresponding prefix will be next to it. So we'll be having increasing elements, and then suddenly we'll drop back to the beginning, and then we'll be increasing again, starting from the smallest element. And in particular, on the position where the two meet, we're going to be having a situation where the element to the left is bigger than the element to the right. So if we see more than one such situation, then of course the array is wrong. But is it enough? Well, it's not enough if we just check that for every position the element to the left is smaller than the element to the right. So we count the number of positions where this happens. And we can't just simply check that it's less than or equal to 1. It's less than 1, so it's 0 when the array is sorted. Otherwise, there is this discontinuity point, and we cannot have more than 1. But while I'm saying that we can do it, you can see that I'm doing it here. And what you have to pay attention to is that this I runs over not n minus 1, length of nums minus 1, but through the whole length of nums, which means that we are not just checking within the array every position if the element to the left is maybe smaller than the element to the right, but we also have to check the first and last element. And only then can we be sure that the array is correctly just a sorted array rotated. Of course, in that case, we can just, with a single rotation, return it to the original array. So we have to check those discontinuity points, but not just in the original array, but in the array that's essentially turned into a circle, in a circular version of that array. And in that case, it'll work because we're not just checking this position of the biggest element being to the left immediately of the smallest element, but also that the position where we start at, when we are increasing, is bigger than the position that we end at, which is the end of the prefix. So that's why we have to check also this first and last element. And of course, in Python, we are doing it because if I is 0, then we compare nums of 0 with nums of -1, which is the last element of the array.